Hello student, welcome back here in Trickle classes. Today we will discuss here miscellaneous exercise of chapter 1 relation and function. Now come to the question number 1. In a question number 1 here we have given f is a function from R to R and fx is given 10x plus 7. Now we will find out the value of g which is defined R to R such that the condition is given g of f is equals to f of g equal to IR. It means we will get here identity. So student, first we will let g is the inverse function of f. G is the inverse function of f. So for inverse function, first we will put here fx is equals to 10x plus 7. Then we will replace fx by y 10x plus 7. Then 10x equal to what? Y minus 7 and x is equals to y minus 7 upon 10. And it is which is equal to gy y minus 7 upon 10, and it is defined from G R to R, and it is the inverse of f. Now we will prove here this condition g of f equal to f of g equal to IR. First we will find out here g of f. So g of x we will write here g of x, g of f x. Now g, what is the value of fx? 10x plus 7. Now we will replace here y by 10x plus 7 in this function. Then we will get 10x plus 7 minus 7 upon 10. These are cancelled and 10 is also cancelled. So we will get here x, which is x equal to IR. Now other side we will also find the value of f of g y. So f of g y. Now f gy is given y minus 7 upon 10. Now we will replace x by y minus 7 upon 10. Then we will get 10 y minus 7 upon 10 and plus 7. 10 is cancelled. So now y minus 7 plus 7, it means we will get y which is equal to IR. So student, we will prove here that f is a invertible function because in these two conditions g of fx and f of gy we will get value of IR. So f is an invertible function. Next question is question number 2. In question number 2, student, we have given f is a function. It is defined w to w. It means whole number to whole number. fn is given n minus 1. N is odd and n plus 1. N is even. Here is given two conditions which are belongs to odd and even. And we will show here f is a invertible function and also find the value of f inverse. So student, if we will show that f is an invertible function, first we will show it is a bijective. What is the meaning of bijective? It means it is a 1 1 and on 2. So student, for 1 1, first of all we will learn by the mapping Venn diagram. So if we will consider here two set, okay, and f is a function and it is defined w to w. Now whole number, so 0 1 2 3 4 and just to infinite. again 0, 1, 2, 3, 4 till to infinite. So student, if here are two conditions, n is odd. When n is odd, suppose n is, we will take here 1 and we will get 1 minus 1, 0. So 1 image is 0. Now n is even, we will consider 0 is a even. So 0, then we will get 1. Now when n is even, it means 2, 2 plus 1, 3, and 3 is odd, 3 minus 1, 2, and 4 is even, 4 plus 1, 5, and 5 is odd, 5 minus 4. So student, as we observe, every element of set A has its image in set B, unique image, so it is a 1, 1, and also we will here observe that all element of set B has its pre-image in set A. No element are left here, because if we will put here even, then we will get odd, odd we will put, then we will get even. So it is 1, 1 on 2 by the mapping. Now we will define here by algebraic also. Now student, for 1, 1, first we will show the function is 1, 1. For 1, 1, we will consider here 3 values. Suppose we will let x1 and x2 are odd. It means both are odd here. So which function we will take here? F x1 equal to fx2. So odd for n minus 1, f x1, sorry, not x1, f x1 minus 1 equal to x2 minus 2, minus 1 is cancelled, so we will get x1 equal to x2. In this condition, it means function is 1, 1. Now other side, if we will take x1 and x2, both are even. So now the condition again we will apply, fx1 equal to fx2. So for even we will put here x1 plus 1 equal to x2 plus 1. 1 is cancelled, x1 equal to x2. So student, in these two conditions, function is 1, 1. Function is 1, 1. But student, if we will consider one is odd and one is even. Suppose it is the case 1, case 2 and case 3rd, we will consider here x1 is odd and x2 is even. If x1 is odd, it means for odd is what? We will get n1 x1 minus 1 equal to, and x2 is even, then x2 plus 1. So student, we will get x1 minus x2 equal to 2. It is not possible. Why it is not possible? Because if we will subtract a even number and odd number, we will get or not get in this condition equal to 0. Suppose we will take here x1 equal to 2 and x2 equal to 3, then 3 minus 2 equal to 1. So we will not get this condition. So in this condition, its condition not follow. Other side, if we will take here x1 is even and x2 is odd, we will get again this condition. So in fourth case, it will be not follow. In these two cases only we will get it is function is a 1, 1 if both are odd and both are even. Now student, for on to, if we will consider here x is a odd. So if we will put here x is odd, then we will get fx is even. So suppose fx is equal to y, x minus 1. So it will become x equal to what? Y plus 1. Other side we will put here x is even. So fx is a odd. Again put y is equals to x plus 1. So x equal to y minus 1 in these two conditions. So student, if we will put here y equal to what? Y equal to x is equal to or y equal to even. If we will put here even number, then we will get odd. And other side, if we will put here odd number, then we will get even. So here we will write x is odd, y is even, and other side x is even, y is odd. It means all we will get all pre-image in set B. So function is onto for x and y, function B onto. Now we will find out it means function B onto, therefore function is invertible. Now function is invertible, it means we can find out its inverse function. So what is the inverse function? F inverse n equal to, suppose we will take it is the GM equal to what? We will get the under condition x is odd, then we will get y plus 1, y is what? Y is even, and y minus 1, y is odd. It is its inverse function. Question number 3. F is defined R to R and fx is given x square minus 3x plus 2. And now we will find the value of f of fx. So student, f of fx, what is the value of fx? This x square minus 3x plus 2. Now we will again replace x by this whole. So we will get here x square minus 3x plus 2 whole square minus 3 x square minus 3x plus 2 and plus 2. Now we will open here algebraic identity a plus b plus c whole square. It will be become x4 plus 9x square plus 4 minus 6x cube, 2 3 is 6 minus 12x, 2 2 is 4 x square 1 2 3 4 5 6. Now we will multiply minus 3x square plus 9x minus 6 plus 2. Then we will solve here, get x4 as it is 9x square and 4x square. It will become 3 1 minute 4x square, yes, and minus 3 and minus 6x cube. We will write firstly minus 3x square, then 6x square, 6 or 4 plus 10x square. Okay, next is 12 minus 12x and plus 9x, then minus 3x here, and here is 4 plus 2 6, and these are cancelled. So answer we will get here like this. It is the value of f of fx. Question number 4. F is defined R2 minus 1 to 1 and fx is given x upon 1 plus x. Now here we will consider two conditions. First is where x is greater or equal to 0, so it will become positive, and if x is negative less than to 0, so we will consider here it is negative. Now student, we will find to show that it is this function is a 1 1 and onto. So student, for 1 1 411. As we know that what is the condition for 11? First we will write here fx1 equal to fx2. Student, in this question we have doing here similar to question number 2. There we will take here that odd and even. So we will consider here both are positive. We will consider x1, x2 both are positive. So for fx1, fx2 is positive. It means x1 and x2 which are greater and equal to 0. So we will write here x1 upon 1 plus x1 equal to x2 upon 1 plus x2. Now doing here cross multiplication, x1 1 plus x2 and x2 1 plus x1. Now we will get x1 plus x1 x2 and x2 plus x2 x1. These are cancelled and x1 equal to x2. So f is 1 1 when both are positive. Now other side, both are negative. We will consider here x1 and x2 both are less to 0. So we will take here second condition, x1 upon 1 minus x1 equal to x2 upon 1 minus x2. First we will write here fx1 equal to fx2. Therefore this now get x1 1 minus x2 and x2 1 minus x1, and we will get x1 minus x1 x2 and x2 minus x1 x2. These are cancelled. So again we will get x1 equal to x2. It means if we will consider here both are negative, then function is 1 1, and both are positive, function is 1 1. But other condition, if we will consider here one is positive and other is negative, so function is not 1 1 in that condition. Now we will write here both negative or positive, then function 1 1. Function is 1 1. Now for onto student, again we will consider for onto, suppose first condition is x is greater equal to 0. So we will take fx is equals to x upon 1 plus x. Now fx equal to y, x upon 1 plus x, then y plus yx equal to x, then x equal to x and 1 minus y equal to y. So therefore x equal to y upon 1 minus y. It is the value of x in terms of y. Second case, x is negative here. So we will take fx is equals to x upon 1 minus x, fx equal to y, x minus 1 upon x, y minus yx equal to x, then y equal to x 1 plus y, therefore x equal to y upon 1 plus y. Now student, we know that y is belongs to what? Minus 1 to 1. It means, what is the meaning of this open interval? It means we will consider that value which are lie between minus 1 and 1. Minus 1 and 1 we will not consider here. So if we will put here minus 0.5, 0.5, 1, then we will get the value of x in these two conditions. So these are, it means it is proved that function b onto also. So we will write here y is belongs to minus 1 to 1, then x belongs to r, we will get, so function b onto. question number 5. If R2R fx is equals to x cube, to show f is injective. For injective, we will show 411 fx1 equal to fx2. Therefore, x1 cube equal to x2 cube. So, x1 cube minus x2 cube equal to 0. Now we will do here factor x1 minus x2 and x1 square plus x1 x2 plus x2 square. So student equal to 0. Now this factor we will not consider because x1 minus x2 equal to 0. So we will get x1 equal to x2. But in this condition x1 square, we will add both sides x1 x2. So 2 x1 x2 plus x2 square equal to x1 x2. Now it will become x1 plus x2 whole square and x1 x2. So student, if we will take two numbers which are the sum of their of square is not equal to their product, it will be not considered. So we will say f is injective because f is a 1 here. Next question, question number 6. F is defined n to z where fx is equals to a and g is defined z to z, gx is equals to mod x. Now we will prove here g of fx is injective but g is not injective. So student, by Venn diagram we will show here it is a f, it is a g, and f is defined n to z and g is defined z to z. Suppose we will consider here how many elements? Natural number 1, 2, 3, 4, and from here we will consider minus 1, minus 2, minus 1, 0, 1, 2, and here is also minus 2, minus 1, 0, 1, 2. So student, if we will put here fx is equals to x, so every image is here fx is equals to x means this all element have there except of negative numbers. Here negative numbers is not take its pre-image. Now in G, if we will define here, suppose put, if we will put here negative or positive number, in G we will put here negative or positive number, so we will get always positive because it is a mod x. Mod x will be become negative number to positive number. So minus 2, 2, 2, 2, minus 1, 1 and 1, 1, 0 is 0. So student, now as we observe here, if we will find out here, it's proved that G is not injective. So we will, as we observe here, element of Z element, all of element of Z element, it's not a given, it's single image because minus 2 and 2 have single image and minus 1 and 1 is also unique. It means two elements, f minus 1, f1 equal to 1. Similarly, f minus 2, f2 equal to 2. So they will not give its single image. So these are not 1, 1. If we were talking about the GOF, suppose it is the GOF. Now we will find out the value of GOF is defined where to where? N to Z. So now we will put here GOF, GOFX. Now we have write GOFX. Okay, now what is the value of fx? Fx equal to, we will put here 1, g of 1. Now g of 1 equal to what? It gives, it is a modulus. G of 1 is given always positive. So G of F1 equal to 1. Now again we will take second element G of F2. So G of F2 is what? F2 equal to 2. So G of 2 is give what? Positive. So G of F2 is 2. As you observe here, every element of natural number has its unique image in Z. So it is a injective. Now we will write here in G is defined, Z to Z here. Now as we observe, G of -1 and G of 1 equal to always 1. So G is not 1 1. Now we will consider here for GOF. GOF is defined N to Z. We will consider x1 x2 two element of N. G of F x1 equal to G of x2. So we will put here fx1 equal to x1, fx2 equal to x2. So G of x1 equal to x1 and G of x2 is equal to x2. So we will get x1 is equal to x2. It means G of F is 1 1. Question number 7. Now in question number 7 we have given f is a function x plus 1 and f is defined end to end and g is also defined end to end. And gx is given x minus 1 where x is greater than 1 and 1 always if x is equal to 1. Now we will show here g or f is onto but f is not onto. So student, by mapping, first we will draw here. It is a F and it is a G. Now as you know, F is defined end to end 1 2 3 4 and it is also N and G is also defined end to end. So we will consider here the number. Now if we will put here x equal to 1, then we will get 2, then we will get 3, then we will get 4. So f is 1 1, but here is one element is left here because 1 is not having its pre-image in set N. So it is not onto. Now gx is equal to x minus 1 when x equal to 1. So it is having image. When value of x is greater than 1, then we will apply this formula 2 minus 1. 2 minus 1 equal to what? 2 minus 1 equal to 1. Now 3, then 2, 4, 3. So 5. Okay. So as we observe here, f is not onto. Now we will talk about the G of F, GOF. So for GOF student, now we find the value of G of F1 because G of F defined to G of F is defined N to N. So now we will put the value G of F1. Now f of 1 is give 2, so we will put G of 2 and G of 2 equal to what? 1. So we will get the value. Similarly, we will find the value of G of F2. Now G of F2 equal to 3. So G3 and G3 is equal to what? 2. So student, as we observe here, G of F has every element of in a natural number and its pre-image to N. And if we will say that G of F is defined N to N, it means suppose it is the A and it is the B. So we will say here every element of B has its pre-image in set A. So G of F is a 1 1. Now onto also, sorry, not 1 1, it is onto. Now we will explain here by algebraic method. F is not onto. Why? Because let one element of n but one has not its pre-image in n. Now for go. So student, for golf is onto, we will prove here. Now let y is element to n, because golf is defined n to n and it is the y we will consider here. Okay, now y equal to x, therefore we will say x equal to y. If y equal to x, we will say here x is equals to y, g of 1 is equals to 1, g of is equals to 2. It means suppose it is a y, it is a x, so y equal to x, therefore we will say x equal to y. Then g of fx equal to what we will get? X, and it is equal to y. We know that g of x is equals to y. So go is on.